Good afternoon to our professor and our friends. Today we are going to present the senior project presentation in electrical engineering project 2 about card quality scanner with having Professor Sijita Jalala Nopalat as an advisor and Natala Saiko, and my partner is Thatpong Thanya Udom. For the overview, trading card game is well known for the card collector popularity worldwide and have diverse player community in different regions, including the Thailand, where most collectors are looking forward to collecting the card that has high value, expensive, and is in good condition. And to make sure that card has scanned or not, collector have need to check by yourself or send to the shop for checking the quality, but it will come with the expense and the downtime. So that's why we have to make our implement big, because that is the best choice for the customer that can serve them more convenience. Our motivation first is for the quality. It shows that people are to collect the card because of beauty, worth, and high quality. If card doesn't have flaw or weak point, that can make people in this group or a lot of people who have interest and want to join our community for the benefit. And this is one of factors that result into the second factor, that is the investment. For this part, some collectors are looking for card collection for long-term investment. They anticipate that the value of the card should be increased over time, and particularly if they are in good condition. Collectors will seek out the high quality card because they are more likely to retain and attract to the potential buyer or the investor in the future. That part is for the time, and 90% surely we know that time is important. In that thought, they don't want to check by yourself or send it to anywhere, cause time is the money. Sometimes people can check, and all the time the price of the card is increased and they are satisfied to sell at this price, but it's not on their hand. This will cause them to lose chance easily. It is better that we can make our implement or the equipment that can respond to the human needs. You don't have to wait a long time and pay your cost. Next, for the feature part, first it is instant. Now card grading system have a long wait time, sometimes 2 to 3 weeks or 1 month, but with our system you can grade and get your card instantly. Second is precision. Our implement can scan for scan and some scan that can be easily missed by the human eye. And the third, that it is easy to avoid the tedious way of looking at the card for a long time. You just insert and grade away. Next is for the trio highlight feature are based on the hardware and the type of mathematical function utilized in comprehension and signal processing. It can operate off the principle of calculating the variation between the sum of the pixel intensity into adjacent rectangular region of an image, and it can apply for object detection in computer vision and image processing, as they can identify distinct objects within an image. This feature can be capable of distinguishing between various objects present in an image. For cassette classifier, there is the machine algorithm used in image processing for detecting objects, which is based on the highlight feature. For this algorithm will work by dividing the image into small subregions and subjecting each subregion to a sequence of classifiers. And this way, this algorithm is able to eliminate large areas of the image that do not contain the object of interest and allowing it to focus on the areas that are more likely to contain the object. For the program, we will use for three programs. First, that is the PyCharm for doing the code. Second is the teachable machine for training the data set and predict the score. And the third, that is Cassette Trinity UI, that is the application that used to train the data set to, but it will work for detecting the object. For the data set positive image, we will select the region that contains scattered and some surrounding areas to provide an overview of the region in a part of teachable machine and image that crop the area having the scat. For the negative image, if you can see, we will choose the image that doesn't have the object of the interest, just only the background. For part of the code, teachable machine, we will use the model to train to and recognize, categorize the different image for non-scat and scat. We use the same distance from the top view as and reference. For using the model, the system must use .headfile file to predict that based on what it has done during the training. For the part code, the code will print the class name and the confidence score, and finally the code makes a prediction using the load model and the input data. The prediction result is stored in the prediction variable and print. For the confidence score, on the left side, that is mean the non-scat part, and the right side for scat part. For Cassette Trinity UI, we will use the input as the data set and input the data set into this folder using the positive and negative image used with the 100%. For the code part, the code is designed to detect the scat in an image and visually highlight with the label and the bounding box, and the resulting image is analyzed and used for subsequent processing that is related to scat detection or image quality assessment. A part is for the grading scale. This code is used to determine the grading scale of a class based on the number of scat it has. The code first prints the number of the scat, and then it will evaluate the length of the scat list using if-else condition to determine the corresponding grading scale. And on the right figure, this is we use it as the reference to determine its overall quality from 10 to 1. 10 is the best and 1 is the worst. For the result, if you can see, the program or the system can detect the scat successfully 100%, and it shows class for scat with confidence score 81%. And for the second result, this one, because there are a lot of the scat and there are the mistake 5 points because of we didn't train for the color that is like that doesn't have that has the light color, not smart. We try to change the color that is contrast a lot, so that's why there is some mistake. For the conclusion, it successfully detects the scratch as intended in the project. Even image with the multiple scan and display the confidence score, which indicates the accuracy of the algorithm. But there are problems in part of the environment such as brightness, light color, and volatile of printing that we can control. But we suspect that if we train the algorithm with such environments more, we can make it detect scan better. And our future work will be focused on more accurate and efficient algorithm for scan detection, especially in arbitrary scan detection. Thank you.